Go ahead and start it. Okay, guys, we're going to get started. Thank you, everyone, for coming today. We had an awesome summer with 13 undergrads and 12 high school students that intern here at ISIS this summer. Before we jump, there's going to be two presentations today, one by each group, the undergrad and high school students. But before we get into that, Dr. Ted Bafty is going to give a few words about the internship program and so. Thank you, Ted.
So just like to welcome you all to ISIS. Glad to have everybody here. A pretty big turnout. I'm surprised how many people showed up. This is Institute for Software Integrated Systems. We are probably the best kept secret in Nashville. Not many people know who we are, what we do. We're a research institute here that does a lot of research for different industry, government, defense kind of projects, and support a lot of students and also a lot of other research going on here. We also have had a very successful internship program over the last couple of years. Brandon has done a fabulous job at coordinating that, and we're really very proud of what the interns have done. And I think you guys will be amazed at what they've accomplished in just a short amount of time, going from ground zero, both at the college level and the high school level. Let's see. So I need to acknowledge the partners and the people who make this possible. So this is funded a lot by the National Science Foundation, provided the money for the internship, so they're certainly very important in this process. Metro Nashville Public School have fantastic support for that, and I know all the guys you're seeing here are products of the school system, and I think they do Metro Nashville proud by what they can do and what they've accomplished. Vanderbilt and Lipscomb are also contributed students for the undergrad, and I guess we have UT as well. I think we have that all. And then got to thank the parents for all the support they have in getting your kids here and making that possible. And then VU and ISIS administration, Susan and her gang, providing all the logistics for this. So that certainly made this possible. And of course, I've already said Brandon here has really been doing a whole lot of work in coordinating logistics. There's just an amazing amount of work that goes into that. And then of course the great interns, and I think you'll see their prospects or their products the work in a few minutes. So I don't want to delay it anymore from the real part of why you're here. So yep, thanks again for coming. Oh, another factor: if you need to use the restroom, there is a code on the restroom. You push number 1, number 5, and then enter. We take our security seriously. So.
Okay. So before we get into the main event, we just have a little treat for you guys. Some of our interns have taken a time machine to get here, so we'll just take a quick look at that. As you see, Ted, who's just up here, is now here in a different form, as well as one more. All right, now we'll get into it. Yeah, you're welcome. Sorry. Nice one. Okay. And the first group that's going to come up is our excellent group of high school students. They will begin. Nolan, yep.
Good afternoon and welcome to the final presentation of the 2014 ISIS High School Interns. Thank you all for coming. As some of you may know, this is the second year of the high school intern program at ISIS. This program gives students that are interested in STEM the chance to work as engineers for the summer. This year's interns are from Martin Luther King, Hume Fogg, and Stratford. I'm Nolan Gross.
I'm Jonathan Stewart.
I'm Asha Ellsbury. I'm Sydney Bales.
I'm Alex Staggs. I'm Zach Bapsey. I'm David Wong.
I'm Jack Upley.
I'm Daniel Hong.
I'm Lucas Coffin.
And I'm Bryce Johnson.
This summer, we were given the simple yet daunting task of improving bikes. From this idea, we focused on making the bike riders' experience safer and more modern. By doing this, we created bike safety lights and a bike computer. Instead of giving you a boring, lame presentation like the college interns might be, we decided to tell you a wonderful story.
Okay, my part. Over the summer, some students from the local high school were asked to participate in a community service project of their choosing. One group of students was having a really hard time coming up with an idea for their projects, and the team leader was feeling a lot of pressure to finalize an idea. One day he decided to go down to his grandfather's workshop for some inspiration. His grandfather was both a do-it-yourself mechanic and a planner. His workshop was filled with to-do lists. Some were finished and some were not. One list he noticed, which was his grandfather's bucket list, was almost finished except for the last entry. To some, the last entry may seem out of place, but he knew that his grandfather had an issue with bikes. He had been in many bike accidents, and he could not even count how many. This gave them an idea.
The group then began thinking about their city's recent push to have a healthier lifestyle through biking. That afternoon, they got together and agreed that they could improve bike safety by adding turning signals, brake and wheel lights, and a rear-facing webcam. It seemed as if the possibilities were endless, so they came to a consensus and decided to design a bike where the rider could add and remove parts, making the bike flexible and modular to the rider's needs. They asked some of their friends to help them out, and each person brought a different skill to the group, such as soldering, programming, 3D modeling, and the desire to learn. However, they were missing a very important component. They needed a way to test the circuits before they went out and spent money on them, because as you all know, the average high schooler's part-time job only pays so much. So someone suggested that they reach out to the Institute for Software Integrated Systems, or ISIS. This institute shared their vision of flexibility and modularity and introduced them to a program that would let them test the functionality of their circuits before they went out and spent money on them.
Now that they had everything they needed, they were able to actually start working on the project. They started by building models of the different parts of the project on the computer. First, they built the electrical components and a program called LT-SPICE introduced to them by the people at ISIS. Within this program, they were not only able to build the electrical components, but test them to see if they would work in real life. Once they finished that, they started working on a CAD or 3D visual model of the cases they would use to house the different parts of their project. They used these models not only to see if it would fully assemble properly, but also to later make using a 3D printer. Once they knew that their design would theoretically work, they started working on the hardware. This included a lot of soldering and even more wiring. And of course, none of this could actually work without a program to tell the lights and the computer what to do. These programs were both very long and complex and took quite a while to make, to say the very least. But eventually, they were able to finish everything and start working on their first prototype of both the LED lights and the bike computer. And although they were able to accomplish this, there was no shortage of difficulties. Things happened, and in this case, a lot of things happened. Sometimes programs didn't work. Often machines didn't work. And sometimes even people didn't work. But in the end, they were able to accomplish their goal of a fully functional prototype.
To the group's surprise, the community started to show a lot of interest in their project. A local bike shop named Microcycle was especially interested and wanted to help take the students' project to the next level. The students explained to the bike shop that their project was only in the initial prototype stage and they had a lot of improvements to work on before they released their product. First, they wanted to make their bike computer a lot smaller using custom microcontrollers and printed circuit boards. They also wanted to make the case a lot more easier to assemble and waterproof. They also had even farther reaching ideas such as web integration so that the user could upload all of their bike ride information to the cloud, allowing them to more easily track their progress. Adding a gyroscope would also allow the bike to record tilting and turning so that custom stationary bike workouts could be generated with the computer. The company thought that this was an interesting idea and decided to that it was a worthwhile investment, not only because it helped make biking much more modern and safe, but that it would also provide a good educational benefit through project-based learning designed around their open source hardware and software.
Throughout the summer, we have faced many challenges similar to those that they faced in the story. The only difference is our bike is real.
This prototype includes a set of front and back wheel lights that displays different patterns and illuminates the bike at night. This allows motorists to see the biker in the dark. These lights not only look really cool, but they're functional and avoiding accidents. In the future, lights may become customizable to the user.
On the back of our bike, we also have a set of brake and turning signals. Those are the turning, those are the brake. And these are especially important for bikers that are biking in the dark so that they can signal cars behind them and wherever going is visible. And we also figured that these braking turning signals are a lot like cars, so they're a lot better known than the traditional braking signals, because honestly, how many people know all the brake and turning signals that the bikers use nowadays? But we figured that since the cities are promoting healthy and sustainable living nowadays, that biking will become more and more popular, and these will be very important in avoiding future accidents.
In addition to these light features, you will notice the large black box mounted on the bike. This houses the components of the bike computer. The computer takes in data from the different sensors and displays them on the LCD screen. And that's one of our sensors. We've made sensors modular. They can be connected and disconnected through the use of telephone jacks. This allows for flexibility in our bike computer that surpasses others in the market. The use of interchangeable sensors allows for broken sensors to be replaced without buying another unit. Our bike computer is affordable in that the user can choose to purchase only the components that they want and avoid having to waste money. Also, because all the hardware is open for development, modularity allows us and anyone else to easily develop software and hardware for the bike computer.
With the large variety of sensors that are implemented into this bike, we created a user interface that is both easy to use and customizable. The program is designed to be easily extended. The code base for the graphical user interface, or GUI, was designed in a way so that new additions could be added to the program, without hundreds of lines of code. We also added several features that allow the user to customize the bike to suit their needs. Once they plug a sensor in, they simply navigate to a settings menu, choose the specific widget they want, and then choose the port that they plug the sensor into. They can then change different settings, like units or other widget-specific settings, to make the bike riding experience more accurate. From there, they can set the display settings. This menu allows the user to set what widgets display on the home screen, so the user can have as many or as few sensors as they want. As mentioned before, all our hardware and software developments are open source, so the limits of our project, there almost are none. Considering we've come into this project with almost no experience, it is amazing we have accomplished this much. We learned things we could never imagine to have learned in a traditional classroom setting. The whole process has really given us a better insight into the everyday life of an engineer. In almost every case, if we didn't know how to do it ourselves, we had to go out and find out how to do it. There were cases where we got some much needed help from the college interns and the faculty here at ISIS, but 90% of the time, we either built off each other's knowledge or went online and learned it ourselves. 7 weeks ago, each of us had 2 or 3 of these skills. Some knew some programming, some knew how to do some 3D modeling, and others knew how to solder. But after 7 weeks of work, there are people who know multiple inheritance, complex cyber-physical modeling, circuit design, and, of course, proper documentation. We are very honored to have been offered this amazing opportunity here at ISIS and look forward to future opportunities and to take our bike to the next level.
Thank you all for coming to support us today. First off, we would like to thank our program coordinator, Brandon Knight, for all the time and effort he put into helping us out. We would also like to thank the college interns for helping us throughout the summer, especially Ryan, Nate, Mariah, Andrew, Caleb, and Mustache Dude, aka Will. We'd also like to thank Dr. Bapty for helping us troubleshoot some of the most stressful bugs in our program, and Dan Furbish from the Oasis Center for providing us with the bike. Finally, we would like to thank all of the people from our schools who helped us get to this point, including Ms. Freeman, Ms. Berry, Mr. Forlines, and especially Mr. Woodbury, who spent a lot of time helping us with the 3D printer. Thank you.
Great. All right. Now I'm going to invite Ryan. Totally just blinked out. Ryan up to do the undergrad.
There's some box seats available if anyone's brave.
Box?
Don't worry about Brandon. He's only known me 12 weeks. All right. Good afternoon, everyone. It's great to see so many people here. We have some people joining us via YouTube, Google Hangouts. For anyone who's joining us today, thank you for being here. Thank you for supporting what we've done this summer. My name is Ryan Coletti, and I'm so excited to have the privilege to speak to you today. But first, before we get into our project, let's meet our team.
No one told you life was gonna be this way. The job is a joke to broke, love like the old way. It's like you're always stuck in second gear. But it hasn't been your day, maybe it was, then you're here. But I'll be there for you. I'll be there for you. I'll be there for you.
All right, we're going to have some fun today. So I and 2 of my colleagues will be talking to you today about our summer project here at ISIS. We've been given the opportunity to follow along with Google's Project Aura and develop some of the very first modules for the world's first modular phone. And I'm proud to announce today that we have 2 modules ready to present to you. But first, let's talk about this project that Google is doing that is changing the world of cell phones. In 2007, Apple reinvented the phone. They presented it as an unprecedented version of a music player, a phone, and an internet surfing device. And that was pretty cool for 2007. For 7 years now, we've been force-fed same versions of this phone. Maybe this one has better screen resolution. Maybe that one we can choose our favorite color. Maybe this one has 4 more icons on the home screen. But they're all basically the same phone, some with sharper corners than others. It's time for a game changer. Introducing the Aura phone, the world's first modular phone. This is a revolutionary kind of phone where you get to choose the hardware, a fully customizable phone. Now, issues like a broken screen or a shot battery do not require us to buy an entire new phone. And if you're a huge music buff but you don't take many pictures, You can buy great speakers for your phone and skip the camera entirely. And if you're always on the go and you have problems with a short battery life, you can buy 2 or 3 batteries and switch them out when one goes dead, even without turning off your phone. It's pretty sweet. So all of this is done by having a phone skeleton and all the parts of the phone, including the battery, camera, speakers, Wi-Fi, Bluetooth, core processor, memory, anything you can imagine, are made into modules that slide into the phone. Here's a video put out by Google that will hopefully help you visualize what this will look like. So Google is producing the skeleton, and they're calling it the Endo. But they've called on hardware and software developers alike to produce the modules. That's where we come in. We are a team of 13 interns, a good mixture of mechanical engineers and software developers. And we've been challenged to create a module that would be useful with the Aura phone. And we came up with a plethora of ideas. Some of our more notable ideas include a power drill, an electric razor, and a flying drone. Some of our more realistic ideas are a key fob, a credit card reader, and an infrared thermometer. We started making a wireless optical mouse and an inductive charger. We had to halt these projects due to insurmountable roadblocks. We're also continuing development on a distress module that comes with a warning whistle and a silent alarm. But the 2 modules we are ready to present to you today are an IR blaster and a blood glucose monitor. We're so excited for these ideas, and we've been able to model these, and we've been able to create cyber models of these that fit within the space constraints of a module. The cyber model was made using a tool created here at ISIS and further developed by a partner company called Metamorph. This tool is a platform that combines programs such as SPICE, Eagle, and System C so that we can model, inspect, and test all of our elements before designing and fabricating them. The Meta tools help cut back on the time required in the design process by combining several steps and streamlining the calculations. The effects of the time-saving software can be seen here. In the middle of the timeline is when we would normally be building, testing, and designing several prototypes. But with the Meta tools, we only had to make 2 prototypes before being ready to design our own custom printed circuit boards and ready to send the plans out to be designed and to be fabricated. And now, to talk to us more about the modules, here's Brandon Thomas with the IR Blaster, starting with a demonstration.
Do you find yourself struggling to keep up with your remotes?
Hi, Andrew Wolfman Wolf here today to show you something really special. It's called the Uniblaster, an IR blaster made exclusively for Google's Aura smartphone. Have you ever turned on a TV? Have you ever turned off a TV? Have you ever seen a TV? Do you know what a TV is? If you answered yes to any of these questions, the Uniblaster is the thing for you. What's this look like to you? A piece of gum? Well, guess what? You're not even close. It's an IR blaster. What you see right here is just a prototype. How do we fit all that in here? I have virtually no idea, but we did. Let's hear from an actual test subject.
So, Juan, tell me about the Uniblaster.
This Uniblaster? Oh God, this one's safe for my job. So,
Let me show you how it works. If you want to turn on the TV, just press the power button. Want to adjust the volume? Just one click of the button, the volume's changed. Want to keep changing the volume? Keep clicking the button. And guess what? There's more. The Uniblaster works with every electronic device imaginable. DVD players, Blu-ray, VHS, Laserdisc, floppy disk. Working on a DIY project? Now you can control your time machine from the comfort of your sofa. Do you find yourself struggling to keep up with the Kardashians? Uniblaster compatible app puts all the controls you need at your fingertips. The price of the Uniblaster has yet to be determined. But I'll tell you what, you send us a blank check and we'll fill in the price for you. No hassle, no mess, guaranteed. Act down while supplies last.
All right. I'd like to thank Andrew again for channeling his inner Billy Mays and helping us introduce the IR Blaster module. That was obviously a lighthearted attempt for us to get you at least half excited about our summer project as we are. First, I want to start off explaining briefly what an IR Blaster is. IR Blaster is basically a loose term used to describe a device that contains both the infrared LED as well as an infrared receiver. Having both these components in one device allows you to both record infrared signals as well as transmit those back, which gives you control of anything that uses an infrared remote. With all the ideas you've seen presented, we struggled to kind of come up with a consensus on what we wanted to actually pursue. And the main reason really we chose the IR Blaster was with mainly mechanical and computer science engineers. We figured we'd start with something simple. We wanted something we could see through from start to end and have completed by the end of this summer. And also, we felt the IR Blaster, with its many uses, was a very marketable product. Now I want to take you through a few of the major steps we took through this summer. The first of these was building a proof of concept. As we said, we wanted to start simple, so we included only a single LED and used a Raspberry Pi interface to control this proof of concept circuit. After we had this proof of concept built, we then used the meta tools, which were so graciously provided by the meta guys, and we modeled the proof of concept here, and then as time went on, we ended up with our final prototype 2.0 model by the end of the summer. Using these tools allowed us to cut out many of the prototyping tests as well as a lot of time-consuming testing stages. Here we can see two of our latter prototypes, the first of which has 3 LEDs included to increase the range, but that is still controlled by the Raspberry Pi interface. And the final 2.0 prototype includes not only a microcontroller to improve the timing of the transmission, but also a acrylite shield which blocks out visible light noise and also improves transmission. Now we kind of just ran through this quickly, so we have another video to show you with some of the more technical details of our project.
Every day, our world becomes more dependent on the electronic devices that surround us. With nearly 1 billion smartphones sold in the last year alone, it only makes sense to integrate these phones with the technological world around us, harnessing the full potential of the one device that never leaves our side. This was exactly our goal in developing the IR Blaster module for Google's RF smartphone.
The IR Blaster module has been designed to allow the user to emulate any infrared remote on their smartphone. Access to existing databases enables users to download the protocols of nearly all devices on the market. If your device happens to not have an existing file, you can easily record all commands by utilizing the built-in infrared receiver. The IR Blaster puts the control of all your devices in one convenient location.
Luckily for us, infrared remote technology has been around for years. However, our main challenges in developing this module were meeting the form factor requirements as well as ensuring its compatibility with our interface, both of which were laid out in the NDK.
To help us meet these requirements, we utilized the Metamorph software tools to accurately model and test our module. The meta tools enabled us to cut down not only on the cost of expensive prototype testing, but also the time involved in the design process. By allowing us to rule out infeasible design choices, we were able to optimize our circuit to fit in the specified module dimensions and achieve the greatest performance, all from a single interface. At this time, our module is operated by keyboard inputs through an Arduino microcontroller. commands are executed by simply pressing a designated key. Our software team has been diligently working to allow our module to be controlled from an Android app interface, and we plan on this being achieved by the conclusion of the summer.
Although there is some software development yet to be done, we are pleased to announce that our hardware design is complete and ready for production. We have a finalized 3D CAD model of the IR Blaster module, as well as a fully designed printed circuit board. We were hoping to have the final hardware prototype to present today. Unfortunately, we did not receive the circuit board in time to assemble the components and show its functionality.
As a team, we are honored to have had the opportunity to work on Project Aura.
It has been a gratifying experience working towards the completion of our ultimate goal.
The development of a fully realized module ready to be manufactured.
All right, so that was our IR Blaster. Our next module we're going to present to you is our glucometer. Nate's going to come up and talk to us about that. But first, we have another video to introduce it to you.
Walking down the street as I check the time. Gotta get my glucose levels in case I'm gonna die. Reach in my pocket, find my phone, wallet, keys. Reach a little deeper, then I start to freeze. Mama left my glucose meter back at the pad. I really need it now when things could get bad.
I heard you left your glucometer back at home. Don't fret, take a breath, I got one here on my phone.
On your phone?
On my Aura phone. So let me see your finger and get a quick grip. In no time at all, you know if you're sick, click, save. Your dad is backed up. You send it to your mom, your dog, or your phone.
Oh man, this is cool, where can I get one? Glucometer on the phone, that must cost a ton.
No, not really, that idea is whack. The starter kit will only cost you $50 flat. Then from there, you just pick and choose what you want on your phone. It's up to you.
What a way to get things started. My name is Nate Bremer, and I will be talking to you today about the glucometer module. For those of you who are not aware, a glucometer is a medical device used to determine the concentration of glucose in the blood. Glucometers use an enzyme-coated test strip that produces a measurable current that is proportional to the amount of glucose present in the blood sample. Today, about 38 million people are affected by the disease, with 5% of those people having to test themselves multiple times a day. Furthermore, about $550 billion is being spent per year on healthcare. There are many benefits of a glucometer module, including its conveniently embedded design. With this module, the data from each test can be collected over time and analyzed by the user or a medical professional. This data, along with data collected from multiple other modules, can be used together to help fight the disease. Because of our internship, we were exposed to the meta tools, a collection of analysis tools that expedited our design process by lessening the number of prototypes. Through the use of the meta tools, we were able to find the final output voltage of the entire circuit, measure certain electrical values within our circuit, and determine whether our components would all fit onto the printed circuit board. Our first proof of concept prototype on the left involved the use of 2 op amps to lower the voltage and to convert the test strip's current into a readable voltage. By treating the test strip as a variable resistor, we were able to measure different output voltages as a result of changing that resistance value. Because the op amps we chose for our first prototype didn't fit the form factor of the module, we had to search around for smaller sized components. Fortunately, we were able to find a microcontroller that had all the circuit components as well as an analog to digital converter with the capability of communicating with the endo. For these reasons and its better reliability, we chose to use this microcontroller in our final prototype. Right now I'm going to show you all a demo of our current prototype as it is. So as you can see here, this is an Arduino Uno. We use this to represent a mock Aura endo, and then our microcontroller right here has been programmed to seamlessly communicate with the endo when it is released. The switch that is being triggered right now is supposed to stimulate the test strip being inserted into the glucometer module. This will turn on the module. The glucose sample we are using right now is a high glucose sample, so we're looking at a value greater than 120, which we were able to get with 138. Now I'm going to show you our prototype app that we have. Currently it is not connected to our glucometer module, so we are using a random number generator for all of our test results. And by clicking in the upper right corner, you can access a log of all your data entries. And simply by pinching and swiping, you can view all the test results from previous tests. Thank you.
Didn't I say we were going to have some fun today? The good news is if you're not having fun, it's almost over. So where do we go from here? Google announced at their I/O conference a few weeks ago that they're holding a competition to find the best R modules created by October 30th. We're discussing continuing development on these two and a few other modules to try to enter them into the competition. As part of the competition, developers can apply to receive a developer's kit from Google, and I'm pleased to say that we have been approved for one. On behalf of all the interns, I would like to say how happy we are to have gotten this opportunity to work on this exciting project. I know we learned a lot and had a whole lot of fun doing it. If you have any questions about our modules or our summer experience in general, we will be available afterwards to answer them. Thank you.
Thanks, guys. So before we close out, I just want to remind everyone there's refreshments outside, coffee and food. The undergrads and high school interns will be around to talk about their projects. And finally, I just want to thank some people for making this possible, especially the admin team, Susan, Christy, Amanda, Tanya, Jacqueline, Eric and Jeff for all the technical support, Tom for all of his help before the summer and throughout since I've been here, Ted, Sandeep, Jason, Janusz for all their help at ISIS and everything they've done with this internship. Mariah, Andres, Andrew for their leadership with undergrads and the rest of the undergrad team for their awesome work this summer. The high school students, all 12 of them, especially Sydney, Luke, Jonathan, Asha, and Zach for coming back and providing leadership. And especially my older brother Justin who works here. He helps me behind the scenes with everything and it's the best. So thank you everyone, appreciate it. Yeah. I forgot to mention Google was watching today on Google Hangout and a few others, so thank you for joining via Google Hangout.
And hire our interns.
And hire our interns, yes. All right. Thanks, guys.